Stability is the tendency of the airplane to return, or not, to the previous flight condition after a disturbance. Longitudinal stability refers to the stability of the aircraft on the pitch axis. It's called this because that movement is in the longitudinal plane, an imaginary plane dividing the airplane down the middle and up and down. This is the green plane in this diagram from John Denker's See How It Flies. When a controlled deflection or outside force pushes the nose up or down, an airplane that is longitudinally stable, or stable in pitch, will return to the original airspeed, or more precisely the trimmed angle of attack. The longitudinal axis of the airplane is essentially a long seesaw hanging from the center of lift. The CG is closer to the nose and is where weight is acting. If these were the only two forces, the plane would tip forward and dive. However, the tail provides a variable downforce which balances the seesaw. It is this tension between the nose-heavy CG and the tail downforce that provides pitch stability. If the CG moves aft closer to the center of lift, the nose downforce becomes less pronounced because of the shorter arm, and the necessary tail downforce becomes less as well. These reduced forces make any sort of stability lazier. The tendency for the plane to self-correct is weaker. As the CG moves aft, the plane gets tippier and twitchier, and if it moves beyond the aft limit, the plane will potentially be uncontrollably nose light, and a stall may not be recoverable. Longitudinal stability is determined by airplane design, but also by the location of the CG with respect to the center of lift. Answer A. Answer B refers to the four forces of flight, which are related to performance, not stability. And while the horizontal stabilizer is very involved in pitch stability, the rudder and rudder trim tab mentioned in answer C have nothing to do with this question.